Don't adjust your screen, folks. I thought I'd play around with a little something different than just the normal white background. The copy and paste into Paint there, though, the text looks a little wacky, so I apologize. I think future ones I'll try something different. But number 65 talks about titanium. It's used in airplanes because it's very strong, very light. In fact, my wedding ring is made of titanium. And is designated, or it has a density of 4.55 grams per cubic centimeter. The cylinder of titanium is 7.75 centimeters long and has a mass of 153.2 grams. We want to be able to work backwards to calculate the diameter of that cylinder. So we get the formula for volume for a cylinder where the R is the radius, the H is the height. In this case, we're going to use the 7.75 as the length here. So a couple things we want to figure out here was our volume. Rearranging our density formula is equal to mass over density. We're going to calculate the volume of this cylinder of titanium using the density of it and its mass. And we're just going to plug in the mass of it, and we're going to divide it by the density. Erase that. Hold on. It's probably going to get all funky on me. Let's fill that back in. All right, sorry about that. I just had to fill in some stuff there that made it look like a parenthesis. I just wanted to make that look like a divide sign. Do this math, 153.2 grams divided by 4.55 grams per cubic centimeter. That's going to give us a volume of 33.7 centimeters cubed. Now we go use the formula from geometry for the volume of a cylinder, and that's pi r squared, which is the radius or the formula for the area of a circle. And now we're going to add to it the height. In this case, we're going to use our length as h. So we can maybe define that here, where h is going to be equal to 7.75 centimeters. All right, so we can rearrange the equation here, and this is going to give us r squared is equal to, basically what I'm doing is isolating this. So I'm going to divide each side of the equation by pi and h. So volume over pi and our height. And if we wanted to get rid of that squared, which we will eventually, we'll take the square root of it. So now let's kind of running out of, well, I'll finish this down here. So we're going to take our radius squared. That's going to be equal to the volume we just calculated up here, 33.7 cubic centimeters, divided by our height, which was 7.75 centimeters. And we're going to want to divide this by pi so that the numbers of digits in pi are infinite, and we don't want to have pi affect our answer in terms of significant figures. So we're going to take pi to at least as many significant figures that we have in our problem. So 3.14, if you wanted to take it to 3.12, that's fine as well. Pi is unitless, it's a ratio. So if I do the math here, I'm going to get r squared is equal to 1.38 centimeters cubed divided by centimeters gives us centimeters squared. I don't want the radius squared. What I'm looking for is the diameter. So what I want to first do is take the square root of both sides of these. That 2 goes away there, and our radius will now be 1.17 centimeters. This the squared there and that radical will go away as well. Since our diameter is equal to twice our radius, all we have to do is multiply this 1.17 centimeters by 2, and that'll give us a diameter of 2.34 centimeters, just under an inch. And that is how you do problem number 65.